Howdy! In this lecture we're going to look at finding the specific heat of a substance. We've already dealt with our two equations for finding heat energy, the Cm delta T equation for changes in temperature and the M delta H equation for finding heat involved in phase change. We are going to kind of put those together in this, and we're going to look at two different ways to deal with that. So here's our example problem. We have 50 grams of an unknown substance at 20 degrees Celsius, and we take and put that into 75 grams of water at 2 degrees Celsius. Now these two substances are at different temperatures, so we are going to exchange heat energy here until they are both at the same temperature, and that final temperature is found to be 5.36 degrees Celsius. We can use this information to find the specific heat of the substance. The key here is somebody's gaining energy and somebody's losing energy. And remember that heat always flows from the warmer object to the cooler object. So the warmer object, this guy right here, the unknown substance at 20 degrees Celsius, and the cooler object, the water at 2 degrees Celsius. So we know that the warmer object's going to cool down, so he's going to lose heat. And the cooler object is going to warm up. He's going to gain heat. All right, so the key here, remember, is that the heat lost, energy is conserved, so the heat lost by the substance that's losing is going to equal the heat gained by the substance that's gaining. So we start all of these with this fact. The substance that loses, the heat energy that gets lost by the warmer substance, is going to equal the energy gained by the cooler substance. But we have to also remember that when something loses energy, the Q is negative. So we're going to put in a negative here to account for the fact that those negative signs happen. So the lost energy is going to equal the gained energy. In this case, we both have changes in temperature. There is no change in phase here. So for the Q lost, it's going to be Cm delta T. And for the Q gained, it's going to be Cm delta T. All right, and so we can just put a little subscript lost here and gained here. All right, so the substance that is losing is the unknown substance, the 50 grams of the unknown substance. So the specific heat, we don't know. So I'm just going to write down C. The mass we do know, it's 50 grams. And the change in temperature, let's take that unit off so the numbers don't get confusing. And the change in temperature, let's see here, final minus initial. Final is 5.36 degrees Celsius minus the initial temperature, which was 20 degrees Celsius. Then on the other side, we have that negative sign, and the substance gaining energy is water. And the specific heat of liquid water, if we're going to deal in calories, is 1 times the mass of the water that's gaining energy, 75, times the change in temperature. The final temperature is the same, 5.36 degrees, and the initial temperature here was 2. So simplifying this and solving, let's see here. Let's plug some of this into the calculator. Okay, so on this side, we have a change in temperature of negative 14.64, and on the other side, negative 1 times 75 times it's 3.36 on this side. So doing the math a little bit more, 50 times the negative 14.64, we've got negative 732. And that's going to equal 1 times 75 times 3.36 gives us 252. So we have C times negative 732 is equal to negative 252. We're going to divide both sides by that negative 732 to solve for C. And now you can see why we put the negative in there. Those two negatives are going to cancel because the specific heat of a substance is always positive. So we just put that in there to make sure we got a positive answer. So 252 divided by 732 gives us the nice round number of 0.344. So C is equal to 0.344. And that's going to be in calories per gram degree Celsius. So there it is. We found the specific heat of that unknown metal. If we find the density of it and we find some other properties of it, we might be able to identify it. So the specific heat is a nice identifying property of a substance. All right, now let's look at another example where we apply the negative Q lost is equal to Q gained equation. Here we've got a nice fun spring break problem because, you know, sometimes we go to places that are warm at spring break and we want nice cold water to drink because it's hot out. So here we have what mass of ice at 0 degrees Celsius would I need to add to 500 grams of water at 30 degrees Celsius to get all liquid water, meaning that all the ice is melted, at 0 degrees Celsius. So again, we have something gaining energy, we have something losing energy. The thing that's gaining energy is the ice, because we have to add heat energy in order to get it to melt. And the thing that's losing energy is the 500 grams of water at 30 degrees Celsius, because it's cooling down. We're taking heat energy out. So again, Q lost is going to equal the opposite of Q gained, because the water is going to give its heat energy to the ice to melt it. Here, this is different from the last problem, though, because we used the Cm delta T equation on both sides. But on the one side, for the ice, it's actually a phase change that's occurring. It's not a temperature change. So the water on this side, on the left-hand side, is actually changing temperature. So we do have the Cm delta T equation for the Q on that side, but on the other side, we're going to have the phase change equation, which is going to be m times delta H. And specifically, this is the heat of fusion because we're talking about melting. So what we're solving for here is the mass of ice. And on this side, this would be the mass of water. So filling in what we know, again, C is going to be 1 because I'm going to deal with liquid water. And we have the mass of the water was 500 grams. And the change in temperature of the water, it ends up at 0, and it starts out at 30. So there's the change in T. On the other side, we have that negative from our equation, and the mass of the ice is what we're solving for, and the heat of fusion for solid water in calories is 80 calories per gram. And so now, simplifying here, we've got 500 times negative 30 on the left, and we have the negative mi times 80 on the right. So we're going to want to solve for mi. 500 times 30 gives us 15,000, so we have negative 15,000 is equal to negative 80 times the mass of the ice. Dividing both sides by 80, negative 80. Again, that negative sign goes away, which is why we put it in the equation in the first place. We end up with our mass of the ice. So 15,000 divided by 80 gives us 187.5 grams of ice is how much we need to add. So it answers the age-old question, what do science nerds do on vacation? They measure out the amount of ice they want to add to their water to make sure that they get the nice cold drink with no ice left. You're going to be doing both of these kinds of problems on your homework, so good luck.